For today's notes, you will need in class 74. This is part 3 of standard 17. Today we're going to be looking at angles that have vertices inside circles. So first, some review. If we look at the angles that are drawn in this picture right now, these are central angles because the vertex of the angle is located at the center of the circle. If we know that angle CAB is 55 degrees, then that tells us that this arc measure out here is also 55 degrees. Angles at the center have the same measure as their intercepted arcs. Today we're going to look at a new type of angle called a chord-chord angle. This is going to be an angle that's formed by two chords that intersect at a vertex that's inside the circle. So this vertex E is where chord BC and chord AD intersect. So what happens when we're looking at the measure of a chord-chord angle is that we have to treat it as being half the sum of two arcs that are intercepted both by the angle we care about and by its vertical angle. The reason why that's important is because vertical angles have to match, but the arcs that are intercepted by the angles might not match. That's not super apparent for those two arcs, but if we looked at these other vertical angles, which are still chord-chord angles, arc AC is definitely smaller than this arc down here between B and D, but these angles need to match. So we can't just focus on a single arc when we're dealing with chord-chord angles. We need to think about both. And what ends up happening if we're looking for the measure of angle CED or AEB is that we need to add these arcs together. So we're going to take the measure of arc AB and we're going to add it to the measure of arc CD and then divide by 2. That averages those two arcs and gives us an angle measure that's halfway between both of them. So for the measure of angle AEC, the one with the star up top, we would need the measure of arc AC and then the measure of arc BD, which might be a major, but it doesn't have a third letter on it, so we're just going to call it the measure of arc BD for right now. Okay, that's all the learning. Now we just need to do some examples and see it in action. So if we're looking for the measure of angle 1, we're going to pay attention to angle 1 and its vertical angle, and we're going to identify the intercepted arcs for both. Since those are both given to us, we can take 38 and 104. We're going to add them up and divide by 2 to average it out. So 38 plus 104 divided by 2 turns out to be 71 degrees for the measure of that angle. For example B, they give us one of these chord-chord angles. So 116 is the angle that comes from the two intercepted arcs being averaged. So this time, our unknown is going to be part of the addition problem that's getting divided by 2, which means we're going to need to use some algebra skills to solve. First thing I would do is multiply both sides by 2 to get rid of that fraction. So that's going to bump this up to be 232 is equal to x plus 128. And then we can finish out our solving by subtracting to get rid of that addition. And so our x turns out to be 232 minus 128, which is 104 degrees. So a little bit more of an equation that time instead of just something to evaluate. All right, next up for number 1, angle 1, we're going to need this arc right here labeled with an X, but also this arc that is intercepted by the vertical angle. I feel like these 44 and 40 degree angles are here to help us out. Those are our inscribed angles from the last lesson that have a vertex on the circle. So this 44 degree angle is half of the arc that it's attached to, which means X is going to be 88 degrees. This 40 degree angle is on the circle with a vertex, so it's half of the arc it's attached to. which means if I'm going to find the measure of angle 1, I now know the two arcs that matter are 88 and 80. So we add them up and divide by 2, and we'll end up with 84 degrees as the measure of that angle. Looking ahead at question D, again, we've got a chord-chord angle that we're looking to find. So if we look at the arc intercepted by the x and by its vertical angle, those are the two arcs that matter. The angle is equal to the two arcs added together, so that second arc just has an x in it, which is fine, and then divided by 2. So another opportunity to do some algebra here. Multiply both sides by 2 to get rid of that fraction, which gives us 2x on this side equal to 1x plus 88. If I combine those like terms, I'm going to go ahead and subtract this x over so that all the x's are together. And that's going to give me 1x equal to 88. All right, we're almost there. We've got 2 more examples here at the bottom of the page. This one is a little bit strange because the angle they've given me would send me out to this arc, and then its vertical angle would send me to that arc, which we don't know anything about. So I think the first thing to do on this problem is to actually subtract that from 180 using linear pairs to fill in this angle as 136. That angle would use this intercepted arc that we have something attached to, and then its vertical angle would use this intercepted arc. So we're going to use the 136 degree angle and say that that would come from or be equal to the 4x minus 12 arc plus the 2x plus 8 arc divided by 2. Multiplying both sides by 2 again to start working on solving this equation would give us 272 on the left equal to 6x minus 4, it looks like, when we combine like terms. So then we'll add 4 to both sides to keep going. That means we're up to, I'm going to come down here, which is a little awkward, 276 equal to 6x. And then to finish that up, we'll divide both sides by 6 to figure out what our x is equal to. It's going to turn out to be 46 degrees. All right. One more problem here. We've got a chord-chord angle here at 95 degrees that would match that vertical angle, which means this arc and this arc would be our two intercepted arcs. I know one, but not the other, so I think paying attention to the fact that this is a diameter will help me. If that is 52 degrees and we've got a semicircle, 180 minus 52 is going to help me to fill in that other intercepted arc that I need to know. So now I'm going to take my angle and set it equal to my two arcs added together, 128 and 5x divided by 2. And then because I've got an algebra equation here, I'm going to go ahead and multiply both sides by 2. That leads me to 190 equal to 128 plus 5x. Subtract that 128 from both sides. Again, I'm going to have to finish down here. Skip over that answer blank. We're going to end up with 62, it looks like, equal to 5x. Finish that up by dividing both sides by 5. And x this time is going to be 12.4. All right, that's it for chord-chord angles. Remember, the angle is equal to the average of the two arcs. So the angle is equal to the two arcs added together and divided by 2. Thanks for watching. We'll see you back in class.